Okay, Assalamualaikum and salam sejahtera. So in this video, we will look at the second part of chapter 1. Okay, in this video, we will look at the topic of convolution integral. Now, this is very famous in tests or even in the final exam. Okay, so what is convolution? Right? Convolution in time domain is equivalent to multiplication in S domain or frequency domain. So we have signals, all right, that signal which we have looked at in previous video. That signal is represented in time domain, okay, in which the y-axis, or sorry, the x-axis is in time, in second. So the convolution, if we have two signals, the convolution of those two signals, okay, is actually or equivalent to multiplication, a simple multiplication between two signals, but the signals are now in frequency domain, right? Never mind. It's quite confusing at the moment, but we will try to understand it, or you probably will understand it much better in the next chapter, right? So basically the convolution means folding. Okay, we'll look at this later. So convolution is an invaluable tool to the engineer because it provides a means of viewing and characterizing physical system. Okay, as an example, we use it to find the response yt of a system to an excitation xt. Knowing the system impulse response is ht. Alright, let me show you an example. Okay, we have the system here. We have the system, and we have the system is represented by gs. Alright, and we have an input to the system, given to the system, represented by rs. So this is in S domain, all right, or if it's in time domain, as an example, represented by a signal like this, step input, right? So this RS is given to the system GS. So the question is, what is the output of that system? The output, the CS. Okay. Now, how can we solve the output of the system? Right? The application can be any circuit, all right, because the circuit, electrical circuit, electronic circuit is represented by system, a complete system GS. So the question is, what is the output? Right? How to solve this? We can use convolution integral. All right. So you can see that it is easier to solve this in S domain rather than using the time domain, right? Because the time domain, it is involve multiplication and involve integration, right? But if it's in S domain, it is a simple multiplication, right? But that is the idea at the moment, right? And yt here, yt is the output of the system, xt is the excitation or input to the system, and ht is the system impulse response, or the response of the system. All right, the response of the system or the system itself. All right. So if we want to know the output, you convolve the input with the system. Right? You want to know the output, you need to convolve. This is symbol of convolution, not multiplication. This is convolution. So you need to convolve, to do convolution, the input and the system. Right? That's the idea. Right? So convolution determines the output of a system for input. All right. So same thing. convolution of two signals consists of time reversing one of the signals, shifting it. Never mind, we'll look at this later. Alright. Powerful, useful tool allows us to obtain the network response, okay, the output of the network to the given input that cannot be written as an analytical function but can be simulated on a digital computer. So you see, if the input and the system is represented by a complex equation, right, it is difficult to solve by simple by normal calculation, but if we can change it into this S domain, simple multiplication, therefore we can just use computer to analyze everything, because it is now just a multiplication. That's what it means, right? We can use convolution to model a circuit which is completely unknown to us, alright, and use this model to determine the circuit response to some input signal. Alright, so basically we can if we have the input, we have the output, we can even get the system itself and so on, right? These are some properties, never mind. Let's look at this example. Alright, this first example of convolution. We have the system which is represented by Hs, or V out over V in. Alright, now the system is the transfer function of the system, alright, is given by 10 over s plus 5. Alright, 10 over s plus 5. And we have the input to the system, that is Vs. Now take note, all these are in S domain. Alright, it is in S domain, not T domain. Alright, the input to the system is Vs, or V supply in S domain, equals to 1 over S. Right? Now let's us use convolution to determine the output voltage. What is the output voltage? Take note here, output voltage in time domain. Right? Output voltage in time domain. What is the output voltage in time domain? Alright. So first step is, we know Hs is equal to V out over Vs. Now we need to find V out. Alright, how to get V out? We have to move Vh here up to here, right? So V out is equals Hs times Vs. V out equals Hs times Vs. Now what is Hs? Hs is 10 over s plus 5. 10 over s plus 5. What is Vs? Vs is 1 over s. So 1 over Vs, right? 1 over Vs. 1 over s. So this is the multiplication of Hs with Vs. Now we have to do partial fraction expansion. Partial fraction expansion to expand this into this. Alright. Now this method, alright, partial fraction expansion, you have studied this before, but I will provide you with a video later on how to perform partial fraction expansion. Alright, never mind, let's just say that we have performed the partial fraction expansion, and this is the result. We get 2 and negative 2. So this is 2, this is negative 2, which is now V out is equivalent or equals to 2 over s plus or negative 2, because this is negative, so now plus is negative 2 over s plus 5. Right, this is the V out, but still in S domain, right? Still is in S domain. Now we need to transform this into time domain, right? Transform this into time domain. Now using Laplace transformation, so this is just simply referring to Laplace transformation table, which I have provided in the end of this slide. Okay, so it's simply referring to the table, you can get this into this. So this is the output in time domain for that system, if the system is being supplied with this input, right? 1 over s. And of course this is actually this figure is taken from different example, so the output is not this is not the output. All right, this is exponential negative at, so this is different signals. All right, so that is one example of convolution integral, right? Next video we will look at graphical approach of convolution integral.